Class, today I'll be teaching you Webster's method of apportionment. Webster's method was used in Congress from 1842 to 1852 and from 1901 to 1941. It carries a bias in favor of states with large populations, does not always follow the quota rule, but follows it more often than Jefferson's method. So for an example of how this method is used, let's say I am the main coordinator of a charity that is going around selling vacuums door to door. I have 30 volunteers and I have 3 shifts. I have one morning, one afternoon, and one evening. So let's say for the morning, I get about 25 sales or customers that would like to buy a vacuum. And then I get about 13 sales, and I get about 50 for the evening. Now moving on. So the way to assign the number of volunteers apportionate to the shifts, we have to find a quota. Now the way we find a quota is by dividing the total number of each of these sales, which would turn out to 88. And we would divide that by 30. Together, this number makes 2.9333. And this will be known as your divisor. Now we use a divisor to divide with the numbers we have here, which would give us our quota. So for 25, we would use 25 divided by 2.9333, and we would get a quota of 8.522. And we repeat the process. 13 divided by 2.9333. We get a quota for the afternoon shift of 4.31. Now for the last shift, we got 50 divided by the divisor, and we get 17.045. Now with Webster's method, we round to the nearest whole number, and we would get our initial quota, which is what we want. So 8.5, that's going to round up to 9. 4.4 is lower than 5, so we're just going to keep it as 4. And 17.04 will just stay as 17. And we would get, and we add these up, and it should come out to 30. If it doesn't come out to 30, then we would need to modify the quota and recalculate everything. So let's do it. So we get our calculator, and we add 9 plus 4 plus 17. And we get the number 30. So the initial quota is apportionate to the number of sales per shift. Thank you. I hope you enjoyed this lesson of apportionment.